Welcome back, guys, to another fun-filled day of physics. I'm going to talk to you guys about the period of oscillators a little bit. In particular, once again, the spring and the pendulum. So there are ways to derive these equations, of course. I don't think we actually know how to do them, and they're a little involved mathematically. So let's just accept these equations. If you're motivated on your own, you can do it, but I'm not going to do it for you because I don't think it's going to be worth your time. So for a spring, we know the period is going to be 2 pi times the square root of m over k. And for a pendulum, the period is going to be 2 pi times the square root of the length over the acceleration of gravity. It's a g. So if we take our basic block on a spring idea, say that this got a mass m and a constant k, that's going to be the period. So there are no other factors that affect the period. And I guess let's draw this for the pendulum too. The dashed line is the equilibrium position. If I say the length, and we know the gravitational field is down, there are no other factors that affect the period. So that's it for the spring. The only factors that affect it are mass, spring constant. For the period, you have length and you have acceleration of gravity. So every so often they'll be tricky and they'll give you some complicated ones where you're accelerating upwards. So maybe I should say, like, we should put in apparent acceleration of gravity here, or relative acceleration of gravity. So because it's not always 9.8. They also like to do some tricky questions where they're like, oh yeah, an astronaut's on planet X and a pendulum is a period of t and a length of L, what's the local gravity? Or give you a graph that he makes versus length or something like that. So just be aware of that. So things that don't affect it that you might expect. Amplitude does not affect the period. Amplitude does not affect the period for small angle oscillations, right? If you go too big, which you can find in your lab that we have later on this week, amplitude will affect it. And yeah. So let's just do a graph real quick. So if you wanted to graph period versus position or something, or period versus spring constant, you'll often see how to linearize these graphs. So let's do period versus mass. So if I graph t versus m, you need to move up a little bit. You're going to get a graph that looks something like this, right? A square root graph. So how do we linearize that? Well, we look at our equation up here, and I say I want it to be linear with m. So I don't want to plot m. I can plot square root of m, or I could square both sides and plot m and t squared. Personally, I like to square both sides rather than square root, just because to me it makes more sense. So what I would like to do to get straight lines, I would plot t squared versus m, and that should get me a straight line. Alright, I'm going to call this one here, guys, and I'll see you in the next one.